Hello, let's solve this problem. We've got a monopolist, which just means monopoly firm, facing a total cost function of q squared and a demand function of, well, that. Find the profit maximizing quantity and price if it is unregulated. Also going to calculate the loss and efficiency due to an unregulated monopoly. So I'll translate that into something else here. What that part means is deadweight loss. Okay. Now what I'm going to do in this video is actually do it graphically, not algebraically. So some things I got to figure out first. So what profit maximizing, anytime you see that, what that means is they're going to produce to the quantity where marginal revenue equals marginal cost. So I need to find marginal revenue, find marginal costs, and plug them into my calculator. Okay. So marginal cost is the partial derivative with respect to Q of the total cost function. So what that is here is going to be, I'm just going to take that derivative, so that's going to be 2Q. Okay, that's the marginal cost there. And then the marginal revenue is the partial derivative with respect to Q of the total cost function. Okay, so what that is, I need to first calculate, let's do that over here, let's calculate total revenue. It's going to be price times quantity. So up here I have quantity, but I find it a little bit easier to rearrange things. Okay, so let's first rearrange so everything gets as a function of price. So let's go over here. I've got Q equals 12 minus P. Just rearrange some stuff. So I've got P equals 12 minus Q. Okay, so now I'm just going to multiply everything for total revenue. Multiply this times Q. I got 12Q minus Q squared. And then for marginal revenue, just take that derivative. So I got 12 minus 2Q. Okay, now I could just set those equal to each other, but I'm not going to do that. I'm going to graph everything. Okay, so I've got my demand function here, my inverse demand function rather, and that's going to be 12 minus Q. I've got marginal revenue, which is 12 minus 2Q, and I've got marginal cost, which is just 2Q. So I'm going to plug these guys into my favorite graphing calculator over here. It's GAlgebra, and we'll make this a little bit smaller here, just like that. Okay, so one thing I want to do is translate, because P is on the y-axis, so I'm going to call price now Y. Okay, so it's just 12 minus X. Okay, and that's going to be the demand function. It's already graphed there. I'll make that bigger in 1 second. And y equals 12 minus 2Q. And then the last one, this is marginal cost, y equals 2Q. Okay, so now got all that stuff graphed. You can see it's already labeling the intercepts. Okay, and I've got, this is the spot where marginal cost and demand intersect. This is the spot where, this is our profit maximizing quantity. Our profit maximizing quantity is 3, because this is marginal cost, that orange line there, and then the red line is marginal revenue. Okay, and what a firm's going to do is then they're going to follow that up to the demand curve, and they're going to charge $9. Okay, so one thing you can do to see it, if it's a little complicated, you can write just another thing that says X equals whatever your profit maximizing quantity is. So that's 3. Okay, so now I can see that, sort of cut that right up there. Okay, and if you don't like that, you can get rid of it. Okay, so now I've graphed everything, and if I wanted to, I can dump it back into Paint. Oops, dump this guy back into Paint. Put it on here, and I can just draw right on it. I can label it here MC. Make that guy bold, maybe a little bit bigger. can label this as P, can label this as Q, label that as D, and then this is MR. Okay, so if I wanted to show maybe the deadweight loss, so that's the loss in efficiency. So it's the difference between what the competitive market would produce, which would be where MC and demand equal each other, so that would be 4, and it would be a price of 8. So it's this, I'm going to shade it here. We'll shade it with a purple or something right here. Okay, shade this right here. It's going to be this. This is our deadweight loss, so we can calculate that. Let's label this here D. Didn't do that very well. DWL. And what do we got here? For that, it's just 1/2, because it's a triangle. The distance between 6 to 3, or 6 to 9, which is 3, multiplied by 1. So that's 1 unit. And I get, in this market, 1.5. Okay, so that's how to take a problem that looks like that, turn it into something like that you can use in various ways. Thank you.